Okay, so we have two types of groups. When these groups, they're attached on position number 1 of the ring, then there's some groups which are 2, 4, 6 directing. Means that when these groups are attached to position number 1 on the ring, any other incoming molecules or ions will attach themselves to either position number 2 or 4 or 6. Usually these groups are the ones that have lone pairs within their structure. The second category are the 3-5 directing groups. When these groups are attached to position number 1 on the ring, then the incoming groups, they attach to either position number 3 or position number 5. Now let's first talk about the 3-5 directing groups. These groups are the functional group of the carboxylic acid, which is this part, COOH, and we have NO2. These both groups, when they're attached to position number 1 on the ring, they deactivate position number 2, 4, and 6, and they activate position number 3 and 5. Let's see. Okay, for example, in this structure over here, we have COOH and NO2 attached on position number 1 of the ring. Because of this, position number 2, 4, 6 are going to be deactivated, whereas position number 3 and 5 are going to be activated. Now let's see the 2, 4, 6 directing groups. Even in this particular category, we have further 2 categories. The groups that activate the ring and the groups that deactivate the ring. The activating ring groups are the methyl group, the hydroxide group, and the NH2 group. And the deactivating ring groups are basically halogens, right? It could be chlorine, bromine, etc. Now let's see for the 2, 4, 6 directing activating ring groups. Here I have the example of methyl. If we have methyl on position number 1, then position number 2, 4, and 6 for incoming groups are going to be open, and 3 and 5 are going to be deactivated. The reason for this is that this methyl group, which is attached over here, is going to contribute its electrons to the pi system of the ring, right? So that's why the position number 2, 4, and 6 are going to be more attractive for the for the electrophile. They're going to be more attractive for the incoming Also, if we see the deactivating ring groups, which mainly constitute of the halogens, we see that they activate position number 2, 4 and 6 as well, and deactivate position number 3 and 5. The reason for this is that chlorine is a really highly electronegative element. So what it's going to do is that it's going to push the electrons, actually not push, it's going to pull the electrons of the pi system of the ring towards itself as well. And thereby it will be allowing position number 2, 4 and 6 to become activated.